I'm going to go over this organic chemistry mechanism problem, where in the previous video, we said that this is the nucleophile and this is the electrophile. So in basic conditions, we're going to look for the most acidic proton, which is going to be specifically this alpha proton here. So this hydroxide ion is going to come in and deprotonate this alpha carbon to generate our enolate ion to give us this intermediate here. Now, even though you see a full negative charge on oxygen, oxygen is not the nucleophile here, because when you do resonance by reforming the carbonyl and popping this double bond onto that carbon, giving that carbon a pair of electrons and a negative charge, the negative charge on that carbon is less stable than the negative charge on the oxygen. That's why this carbon here is the nucleophile, not this oxygen here, right? Now, we can reform the carbonyl and have this nucleophilic carbon attack this carbonyl carbon, forming a new bond between the nucleophile and electrophile. And we would have to push the bond onto the oxygen here to conserve the octet role. And here we are going to form a 1, 2, 3, 4, 5-membered ring, where every single atom in the ring is a carbon atom, which will give us this intermediate here, where 1 was the nucleophilic carbon and 5 was electrophilic carbon, making this the neo bond between the star and dot, between the nucleophile and electrophile. Now, 3 and 4 has CH2s, 1 has an isopropyl group, 2 has a carbonyl, 5 has a tert-butyl, and it used to be double bonded with oxygen, but that got popped up into an alkoxide ion like that, right? Where we could protonate it using the protic solvent we have, water. Because we're given heat and we have an alpha proton in between the carbonyl and hydroxyl group, then we could do auto dehydration, where this alpha proton here is the most acidic proton in this whole molecule, will be grabbed by this hydroxide ion to generate this enolate ion here. Okay, now once we have this enolate ion over here, reform the carbonyl, shift this double bond over here, and kick out this hydroxide group, giving us this alpha beta unsaturated carbonyl. And another question I had was also, why is this alpha carbon not considered a nucleophile at all? It's because the nucleophile for this mechanism is an enolate ion, and to generate an enolate ion, we need to deprotonate it, but this alpha carbon here has no protons to deprotonate. And I hope that helps. If you want free organic chemistry tutoring from me, DM me organic.